Okay, so if we want to answer a question like the one on the left-hand side, points A and B have position vectors of 3i plus j and 11i plus 6j respectively, and we know that point C lies on the same straight line as A and B. We're also told the lengths A to C and B to C are in the ratio of 3 to 2. We need to be able to show there are two possible positions for point C and find the position vector of each. Well, the most important thing when you're answering a vectors question is usually to draw a diagram. So we know we've got two options for the position of C here. So first option, C could lie in between A and B. So if I draw a line going from A to B, C could lie somewhere in between that. And then I just need to apply that ratio to what I've drawn. So I'm saying that this is 3 parts, where this bit of the line is 2 parts. Now I've simplified everything here and drawn it horizontally just to try and represent the two different possible positions of C. Obviously the I and J vectors actually tell us that this would not be just a straight horizontal line, but I think visually it helps us see the two different options. In this case, I know that I can figure out the movement from A to B really easily because I've got the two position vectors, but it's worth applying what that means to my knowledge of where C is. So option 2, C could lie beyond the line AB. So I could have A and B like that, and then C could lie somewhere right over here. But again, that ratio has still got to be true. So if I call this whole bit 3 parts, this bit here has got to be 2 parts. So you can see that the line A to C is kind of 3 times longer than A to B. So here are the implications. If we look at option 1 again, if I consider the line A to C, or the vector A to C, I know that that is 3 parts of the way from A to B. So it's 3 out of those 5 parts. So it's 3/5 of the movement from A to B. Below, on the second option, it's a little bit different. As we just spoke about, that whole line from A to C is actually 3 times longer than the line from A to B. Now, if that makes sense to you and you want to have a go at answering this question, you can just pause and attempt it yourself. If not, I'm going to do the solution for the two actual position vectors of C on the next on the next slides. So here we'll really focus in on option 1 with C lying in between A and B. So first of all, it's really important that we can represent the distance of the movement from A to B. So we find the difference in the I vector and the difference in the J component, So 11 take away 3 means I've got 8I, and 6 take away 1 means that I've got 5J. So I know that AB as a vector is 8I plus 5J. We know that AC is 3/5 of that. We looked at why that was the case a minute ago. So all I need to do is 3/5 of those two components. So I know to get from A to C is 4.8I plus 3J. Now, it doesn't actually want that as my answer. It wants the position vector. So I don't want to know where C is from A. I want to know where C is kind of from the origin, if you like. So the position of my first option of C with a little 1 is the first potential option of C. I still need to add on the position vector A to make sure that I'm going all the way from the origin. That's why I need to add that on as well. So the position of C1 is actually 7.8I, because I had those 3 I's on, plus 4J, because I had that 1J on from the position vector of A. Now let's concentrate on option 2, if C were lying beyond the line AB. So we know that A to C would be 3 lots of AB, as we just discussed. And working out position of C2, this time I'm calling it C with a little 2 because it's the second option of where C could be, we still need to know how to get from A to B. And we already did that with our first option. So we know that that's 8I plus 5J. AC this time is 3 times that movement, so it's 24i plus 15j, and again that only tells me the movement to get from A to C. We actually want C as a position vector, so we want that from the origin, so we have to add on the position vector of A as well, so that we're going from the origin. So we add 3 i's and 1 j on, and we know that the position of C2 is 27i plus 16j. Have we shown that there are 2 possible positions for point C? Well, yes, we have, because there they are, position of C2, position of C1.